not something you should try at home, but our next workshop is. Join Peter, the founder of Mechatrons, for our next engaging DIY electronics workshop where you can build your own motor.
Hi, today we're going to learn about motors. All the robots that I've built all have motors in them, different types of motors we use. We use servo motors, we use stepper motors, we use brushless DC motors, and we use DC motors, but they all work in the same way. They all use power supply, electricity, they use magnets, and they use electrical magnets made from coils. So we're going to have a look at making those today, making simple versions of motors. To make this, we're going to need pliers, a sharp knife, some neodymium fridge magnets, a AA battery, some electrical cable. Okay, we'll start with this, our electrical cable. This is twin and earth electrical cable, and I want the earth wire out of this. So I'm going to use my knife and be very careful. I'm just going to split the end of this wire here. At the very end of the wire, just put the knife in and pull it towards the end like that. Then open up the electrical cable like this, and it will expose the two wires. This is two browns, but you might have one that has a brown and a blue. But I really only want this piece of copper wire here that's in it. I'm going to use the pliers to grab that and just pull it out like this. There we go. I'm just going to fold it in half and pinch the top of it so that we get a nice little fold just like that. Turn it upside down and make it into a kind of a heart shape. I'm going to make quite a wide one, I think. Oh, cool. The next part I need is I want to measure to just below the bottom of the battery, like that, and then fold it out. So I end up with this cowboy hat shape. I'll put one of these back and one of them forward. So now I have a wonky cowboy hat. And I'm going to attach the magnets onto the end of the battery. Now I have my battery with the magnets attached. And this is going to conduct electricity through the magnets. So if you've got the black magnets on your fridge magnets, they probably won't work. These silver ones will allow the electricity to conduct, whereas the black ones may not. So see if you can find these silver ones. They are neodymium, and they allow the electricity to flow through. That is going to fit just there. So I can see that I have made these just a little bit too long. I want them to touch these magnets at the bottom and not go below. So I can either add more magnets here, or I can just change the bend on that, which I'm going to do. Now, using the battery as a template, I will bend the wire around the battery to make a little loop like that. Same on the other side. When I bring them in together, they're going to hug the magnets on the bottom. Just touch off them. This is the shape I'm after. So I want this heart shape here, and on the bottom, I want this battery kind of shape here where it's just going to pinch and hug the magnets at the bottom. So we just attach that on here, and there we go. Look at that. We've made an electromotor. The coil of copper wire that we made is generating an electromagnetic field, and the magnets on the bottom are pushing that magnetic field and making the coil spin around. And that's exactly how a motor works. Of course, motors will have a lot more coils of wire in them, so they'll be more powerful than that one. I can stop that one with my finger. But isn't that cool? Let's make another one. To make this, we will need pliers, a sharp knife, some insulation tape, some neodymium fridge magnets, a AA battery, and some varnished electrical cable I've harvested from an old transformer. Now it looks very similar to the copper wire that we're using here, but actually this has a varnish on it, and the varnish means that it's insulated from itself. So if we make a coil into that, it doesn't make an electrical circuit by touching itself. And I will start by taking my insulated cable. I'm going to wrap it around the battery a couple of times. So I'm just going to hold it there like that, and I'm making a coil, an electrical coil. So I'm going to just wrap it around the battery like this a few times, make a few loops to make an electrical coil. And then I'm going to put the ends of the cable through just to hold it all together so that it stays a circle. And there we go. I've made myself a little electromagnet. That's going, when electricity flows through that, it goes around and around and around, comes out the other side, and it generates a magnetic field. And when we put that close to another magnetic field, it will have either it'll attract to it or it'll pull away from it. So we need to get electricity to flow through that. And what we're going to use is our battery and 2 paper clips. So I'm going to just tape a couple of paper clips onto the end of the battery. First, I will just flip it up this way so that the loop is at the top, like that. Do it with the other one, like this. And I'm going to just tape them onto the battery here. So there we go. This is going to sit on inside those little loops that we have on our paper clips. Now remember that varnish that I was talking about. This, by the way, this wire comes in different colors. This one is kind of copper color, so it's going to be difficult to see the difference, but it can come in red and green and blue. And if you have a red one, you'll be lucky because you'll be able to see when you get the varnish off. And I'm just going to scratch away at the varnish, but I'm only going to do it on one side of the wire. And the reason for that is that I need the wire to be able to make and break the electrical connection as it turns. So as it turns, the bit that has no varnish on it will make an electrical connection, which will make a magnetic field. And then as it turns, it'll touch off the piece that has the insulation on it, and it won't make any electricity, so the magnetic field will drop. And that will make the coil want to turn again, and then it will build up the coil, the magnetic field again, and then it will go off and it'll go on and it'll keep going on and off and making the motor want to spin. So I'm only going to do that side of it, but I also have to do the other side of the coil. So I'm keeping on the same side like that and scratch this side off. So now my coil has bare metal here and here, but if I turn it over this way, it's insulated with the varnish here and here. Just put 2 little magnets there. And then we need to put our, now my loops I have put it in there are too low. It's actually touching the magnet. It's not going to be able to spin. So I need to raise them a bit higher. You want to try and get them so that they go all the way through like that. And you want to try and get this as balanced as you can so that that's as close to the center of the circle. The more balanced it is, the better it'll turn. Okay, my loops aren't good. What's happening here is that as it's trying to turn, it's popping out. So I just need to close my loops so that they are closed, so it won't fall out again. Okay, here we go. So there we go. That's an electric motor made out of a battery and a coil that we just made with a fridge magnet. Now, I want to show you something really, really cool. For this experiment, we will need a tube of aluminium kitchen foil and some neodymium magnets. And if I drop them in here, what will happen is this roll of aluminium becomes an electromagnet, and it opposes the force of the electromagnet of the normal magnets falling through it. So actually they'll fall through at a slower rate than they would normally. Now it's kind of hard to see that happening, but they are actually falling slower. What I will do is, I've got this giant magnet. This is a really strong and powerful neodymium magnet. If I put that in here, it's going to take quite a while to fall through. Look at that, that's cool. And that's because it's generating a magnetic field in this aluminium. And that magnetic field is opposing the magnetic field that it has by itself. And slows it right down. And I could actually let that go through and then turn it upside down. And keep just doing that, and the magnet is going up and down in there without falling out. But it's not caused by the friction. This is quite a close fit to that, but it's not the friction of the magnet against the cardboard that's slowing it down. It's actually magnetic forces. That's really how the motors are working as well. So the motors are working by this magnetic field pushing or pulling. And I'm going to show you exactly something really cool with that right now. To make this, we're going to need a sharp knife, some single core electrical wire, a drill, neodymium magnets, a AAA battery, and a 12mm bar. This is a little electromagnetic train. It's made up of a AAA battery and 2 fridge magnets on each end. And we're going to put it into this coil that I made of wire. And as we put it in, it races across. That's kind of cool. I like that. Do that again. There we go. And what's happening is that as it goes through the coil, the ends of the battery make connection with the wire through the magnets, and they generate a magnetic field in this coil. Pulls the first magnet through, and it pushes the back magnet through, so it ends up pushing and pulling the magnet, the whole car or train through the field like that. So how did I make this? I just got some basic single core wire. It's important that you use single. And I stripped all the insulation off it. I got my knife, and I just hold the knife on the table like that, and I pull. And there we go. Now that I've got that split all the way down, I can just pull the insulation off, and it will come off all the way off for the whole cable. Now that I've stripped all the insulation off my single core wire, I got a bit of a bar here. You could use a piece of stick, you could use anything long enough really. It's got to be just wider than the magnets so that the magnets can float through it. And the magnets have to be just wider than the battery. I've drilled a little hole in here to make it easier to start off, and then I can just wind it like this by hand. But to make it quicker, because I've got a lot of it, I'm going to just put it into my drill. Okay, so what I'm going to do is I'm going to use the drill on very slow speed, and so that it doesn't burn my hand if it gets too fast, I'm going to use this cloth, but you could use a glove if you wanted. And then just slowly. And there we go. We've got our spring or our train tracks made for our electric train. So I'll just pop that out of there, slide it off the end, and this is what you end up with. And you might see that at some points it's a little bit wider, and other points it's too close together. So we don't really want this wire to touch because it's not insulated like the other wire that we had, the varnished one. So we've got to make sure that there's some gap between the parts, but we don't want it too wide like that. And you can push it back together and it should be okay. Or if it's too close together, you can just pull it apart a little bit. Now the little car that we make, I've got 2 magnets on one end, 2 magnets on the other end. But it's important to have the polarity the right way around. Now they're pushing away from each other. So if it wants to stick together like that, there they are stuck together, that's the wrong way around. I want it to be that way where it's pushing against it. And when it's pushing against it, so they don't want to go together, I turn this around and attach it to there. This way we have opposite polarities at each end, so it'll push one way and pull the other. And now when we put it in, off it goes. And if we had time, what you could do is make a longer one of these and make it around into a tube like this. and the little car will just run around and around and around and around till the battery runs out. So there we go. We've made ourselves a little electric train. Well, thank you for watching this. I hope that at home you managed to get your little motors to run or your little train to run. All of this electromagnetic stuff doesn't matter what kind of motors you have, what kind of robots you use. This is how it works. It uses magnets, it uses electricity, and it uses coils to generate that pull and push force for these motors. So I hope you enjoyed that. Thank you.